Electromechanical solenoids are devices used to activate anything requiring a quick and powerful linear motion. You probably have a number of solenoid-operated devices in your home. Power locks on a car are often activated by solenoids, and the numerous cycles of a dishwasher are controlled and activated by solenoids. Manufacturers use solenoids to control and operate the specialized equipment used on modern assembly lines. Solenoids function by using the magnetic field that appears when electricity flows through a coil of wire. The moving needle in this compass reveals the presence of a magnetic field. Well-designed coils can produce powerful magnetic fields. I'm going to build a simple solenoid using 12 meters of fine insulated magnet wire, a 4-inch common nail, a straw, and 4 AA batteries. I start by wrapping 12 meters of 28 gauge magnet wire close to one end of a straw, creating a coil. I have to leave both ends of this coil exposed. Magnet wire is coated with a clear insulator. I'm using sandpaper to remove this insulation, exposing the bare copper wire. This 4-inch iron nail fits perfectly into the coil end of the straw. Connecting the two leads to a battery, we witness the magnetic field moving the iron nail. Here I've mounted the straw vertically, with the nail extending from the bottom. I'm using 4 AA batteries to energize the coil. Making the final connection, the coil is energized and the magnetic field lifts the nail. Break the circuit and the nail drops. I'm using gravity to return the iron nail to its original position. Many solenoids use springs to return the iron core to its start position. I'm only energizing the coil for a few seconds. It can get hot. We can see how the linear motion of this mechanism could be used to control the locks on a door or open and close the valves in a washing machine. In robotics, if a quick motion is required, solenoids are often used. This is another device that uses an electromagnetic coil. It is similar to a solenoid, but it is used to control electricity. It's called a relay, an electromagnetic switch. You can see the fine wire coil in this relay. When the coil is energized, the resulting magnetic field pulls these two contacts together. They are joined to these two connectors. This is where you would connect a circuit. The contacts would switch it off and on. When I connect 6 volts to the coil on this relay, you can see the contacts closing. The specs for this relay state that it can control up to 10 amps at 250 volts AC. Relays are found on many systems that are used to control electrical functions, particularly when a small switch is used to activate a high amperage current. They are common in automotive applications. The fuses and relays in this Ford truck are located under the hood. These devices are relays. Turn on the air conditioning in this truck, and the small current from the dashboard switch energizes a coil located in this relay. The coil pulls heavy-duty contacts together, contacts capable of handling the large current needed to engage the air conditioner. The electric starting motor in a vehicle uses a very large solenoid relay system that is activated when you turn the ignition key. Without a system like this, the small switch on the steering column would melt. I can demonstrate a model relay using this basic solenoid. In this example, this simple relay is controlling an electric motor. The motion of the nail controls the switch, connecting and disconnecting the battery powering the motor. Study the video and you can probably see how it works. Don't attempt any project like this if you are unfamiliar with basic safety procedures when working with electricity. Ask your science teacher or a knowledgeable adult for help. Even small batteries can cause serious burns when short-circuited, and never experiment with high voltage or anything that plugs into a wall outlet. For more science and technology videos, visit our website, hylaroad.com.